discuss on the basic definition of the solid. The solid is nothing but the body which shows a definite shape, a size, or a value. So the body possesses a definite shape, size, and a value. Those objects we are calling it as a solids. In the solid, the intermolecular arrangement of the atoms are fixed. See, these are all intermolecular arrangement. So whenever I am applying force on this object, then what will happen? The position of this molecule will not changes whenever we apply the force on the material. So the position will remains the same. So then those objects we are calling it as a solid object. The solid object possesses a large number of properties like elastic nature. The first thing is the properties of solid. In the properties of solids, the first property is elasticity. So the elasticity meaning is whenever force applied on the material, there is a change in the length will occur. So once we remove that load, then what will happen? It will regain its original shape. For example, consider there is a spring which is attached here. So in the downward direction, I will put some weight or I will apply some force on that material. Then what will happen? The length of this object will be increases. So after applying the load, the length has changed. But once I remove that load, what will happen is it will regain its original shape or it will regain its original form. So this is called as elasticity. See, this is a spring. Here what I am doing is I am applying the force. So because of the force, what is happening is the length of this spring wire increases. And once I am removing the load, then what will happen? It is regaining its original shape. So this is elasticity. The next comes plasticity. The plasticity is whenever we apply the force on the material, then the material will not regain its original shape once we remove the load. So consider for the same spring, once I have applied the load in the downward direction, then what will happen? The length will increases, and once I am removing that load, then what will happen? It will not come to its original shape. So here it regains its original shape, but this plastic nature, it will not regain its original shape once we remove the load. Once we remove the load. The next property is ductility. So in the ductility, we are using this property in order to prepare the wires. Thin wires we can prepare here. See, these objects have a long range of plastic nature. They have long range of plastic nature. See, once we apply the load, the material suddenly it will not break. It takes some time in order to break of that material. So it has a long range of plastic nature. The next is the brittleness. It has a short range of plastic nature. It has a short range of plastic nature. So this object will break suddenly. The example for this brittle material is our chalk, and example for ductile material is our pencil, and example for this plasticity is our plastic bottle. example for this is a spring. And here in the ductile and the brittleness, whenever we apply some force, the material will break, and during the breaking, ductile material indicates some changes in the shape of that material. See, like this it will come for the ductile material, but brittle material will not show any deformation at the breaking point. So it will break like this. For example, that I have already told, the chalk, after applying the load, what will happen is it will suddenly break. It will not. It has a short range of plastic nature, and there is no deformation of the material at the breaking point. But in the ductile material, what will happen is at the breaking point, it will show a deformed shape of the object. The next property is malleability. So in the malleability, we are using heat as well as a force. So both the things we are applying on the material. So whenever we are applying on the material, then what will happen? We can prepare a thin sheets. We can prepare the thin sheets. For example, in the car, the body structure will be manufactured with the help of this malleability property. So till now we have discussed about what is solid, which has a definite shape, size and a volume, and some of the properties of the solids. So with the help of these properties, we can use the solid for different applications. For example, in the manufacturing of the car, we can use this malleability property, and in order to prepare a chalk, so brittle material we are using, brittle property we are using, and in order to prepare a spring, the elastic nature we are using. So likewise, with the help of the properties of the solids, for different applications we are using. The next comes the stress. What is the meaning of stress and the strain? The stress is nothing but it is a restoring force developed when a force is applied on the material. Restoring force developed when the force is applied on the material. See, this is the spring. What is happening is, see, whenever I am applying the force on the downward direction, then what will happen? My hand is experiencing some opposite kind of force. My hand is experiencing some opposite kind of force. See, till now I am not experiencing the larger force, but here I am experiencing a larger internal resistance force developed by this spring. So the stress is nothing but internal resistance force. The stress is nothing but internal resistance force developed by the object, resistance force developed by the internal resistance force developed by the object when a force applied on the material. So when if we are not applying any force on the material, that stress will not develop. Force applied on the material. And this is also known as restoring force. Restoring force means, see, it has a capacity to regain its original shape. See, restoring force. So whenever I am applying the force and I am removing the force, then what will happen? It is regaining its original shape. This is because of the stress developed inside this material. So the restoring force is developed. So the formula for stress is the restoring force divided by cross-sectional area, and The unit of stress is, force unit is Newton and area is meter square. So Newton per meter square is the unit of stress, and its dimensional formula is, see, the force is mass into acceleration and area is meter square. So the mass is m and acceleration is meter per second. So that I am meter per second square, that I am writing it as a LT raised to minus 2, and this area is meter square, that I am writing it as a L square. So m L T raised to minus 2 and L raised to minus 2. So this brings m into L raised to minus 1 and T raised to minus 2. So this is a dimensional formula for the stress. And this stress also develops on the liquid as well as the gases also. So in that case we are defining stress as, stress is equal to pressure divided by area. Pressure divided by area. On the liquid and the gases, this formula can be written as a pressure divided by area. So this is also, the formula is, means dimensional formula and it is the same. The next comes a strain. The strain is nothing but whenever force applied on the material, there is a change in the configuration of that material. Whenever the force is applied on the material, then what will happen? Then there is a change in the configuration of the material. Configuration means there may be increase in the length, there may be increase in the area, there may be increase in the volume also, or we can call it as a